What is a superfluid?
So now, what is a superfluid? A superfluid is a fluid, say like water, but it has no viscosity at all. Now, you probably ask the question, what's viscosity? Viscosity is the friction that a fluid experiences with itself. So in other words, like the friction between my two hands, they rub them together, it generates heat, so there's friction. That's what stops it. And a fluid can actually have friction with itself.
So when you pour water into the bowl, you can see that it fills the bowl rather easily. You get some swishing around and some stuff. You can sort of see how the water interacts with itself, but it's a very clean and easy fill. In contrast, honey, which has a much higher viscosity than water, will take a longer time to pour out of its container and into the bowl. It'll also take a longer time to settle, and that's because the amount of friction that it has with itself is much higher than water, i.e. it sticks better to itself than water does.
So in contrast, a superfluid would probably fill the bowl up rather quickly. Now, to be fair, it might look a lot like water because viscosity for water isn't actually contributing that much to what's going on, but you still get the idea. But that still at least illustrates the idea of viscosity. Now, there are several really, really neat experiments that you can do with superfluid. The first is that, in fact, superfluid doesn't boil. If, let's say, I take water and I put it in a pan and I heat it up, you'll start getting bubbles of boil out from it. And that's because what's going on is that the temperature inside of the water is not uniform. And so the parts of the water that are actually able to suddenly turn from a liquid into a vapor can be actually inside the liquid itself and usually forms on the side of the walls. And then that actually is able to vaporize and turn into a bubble and lift up. But in a superfluid, the heat is uniform and the heat is transferred instantaneously throughout the entire fluid. So any amount of boiling, any heat to boil anything off will just come off the surface. And the second is actually something called the fountain effect. And that's where we take a heater and we take a bunch of powder and we put a bunch of powder in here so only superfluid can flow in and a little nozzle at the top. And if I heat this little piece of heater, the superfluid will actually flow and flow out because it's all going to go rush towards that heat. It's looking where the source of the heat is to make sure that the heat of the entire fluid is uniform.
So here you have boiling helium, and we're pumping on it to get it to boil. And so you have this nucleation all randomly, and that's because the heat is non-uniform. But once it becomes a superfluid, the heat is uniform throughout the whole fluid, and it stops boiling. And now here we have the fountain effect. And this is done by taking a heater and across a very, very fine powder and applying heat there. And so only superfluid can pass through. So if I apply the heat, the superfluid rushes to the heat because it's all going to try and control the amount of evening out the temperature, and that superfluid just shoots up with all that force that I'm created by generating that heat through the nozzle, and that shoots the superfluid up. So this is literally the way to take advantage of superfluid and quantum mechanics to actually make a jet of superfluid, a jet of fluid just pour out without using any mechanics at all. This is just done with heat, and I think that is super, super, super cool. And you'll notice in a moment when it comes down. This is actually video that's been slowed down to about 1/100th the speed of a normal event. So you get to kind of see it all in its fantastic glory, and it's a really, really cool thing to watch. All of his videos were done at the University of California, Irvine. I believe they were actually done around 2010. Actually, this was the point when I was a graduate student there, so this is why I have his videos. And they're actually on YouTube as well under UCI Low Temp. So enjoy them.
This has been a video from Van Cleve Scientific. If you like this, please like and subscribe for more content.